So what we're going to do, this may look similar to what you learned last year with constructions. The only difference is now this is the next level. The next level is, will you be able to find the circumcenter? Will you be able to find the incenter? Will you be able to find the orthocenter? And there's one other one that we learned, which is called the centroid. So of those four shapes, that the four different types of concurrencies that are in a triangle, we're going to actually do them with our compass and straight edge. The two major things that we're going to use are perpendicular bisectors. You learned how to do this last year. You also learned how to do this last year. If you need to write down steps, then write down the steps to do it. If you need to come back to this video later, I will post this video on my website in case you want to see it step by step. Other things that I've included, I actually do have a website that you could go to that will show you step by step how to do these constructions, and they are right next to the problem in case you need further assistance. But let's go ahead and start with number one. I'm going to pick selectively certain ones to do with you, and then you guys will do the rest of these on your own. If I was doing a perpendicular bisector, what I would do with this, the way these compasses work, these are called bullseye compasses because, I don't know if you can tell us, but there's a bullseye. That's the center. I'm going to put my bullseye on, what letter is that? L. I'm going to put my bullseye on L, and then what I need to do is I need to adjust the slider until it is more than halfway to M. It doesn't matter how far past halfway, you just need to be more than halfway. And then you're going to tighten it up. So I'm going to make sure my bullseye's on L. I opened up my compass more than halfway, and then what I do is I take my writing utensil and I put it usually within the first hole, and you can make an arc from L. That's my first step. And ideally, I am going to have enough room so that when I go and move my bullseye to M, that I will have two intersecting points. With constructions, you always want to have two places of intersection. If you do not have two, you're not doing it correctly. What we now have is a distance that's the same as this distance and another distance that's the same. And according to what we learned in our previous section, by side, 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 we could have a triangle that's the same, which means that when I connect these two things, we now have a perpendicular bisector. You have to connect from this intersection to this intersection. If you don't believe me, you could check, is that a perfect 90-degree angle? Or you could even measure from here to here, and I think this is 6 centimeters long. Is that going through the midpoint? And it should be. It's a way for you to find it without even using a protractor or the compass. So if that's how we do perpendicular bisectors, what you're going to do is you're going to use this on number 2 to find the circumcenter. You are going to do a perpendicular bisector of this side and a perpendicular bisector of this side, and where they intersect will be the circumcenter. I will do one side with you and let you do the rest on your own. So for example, if I was doing that same thing with J and K, I would put my bullseye on J, make sure that I was more than halfway, and because I don't want it too big, I want this to fit on my piece of paper, I'm just going to go just a little more than halfway and make my arc. from J. And now I'm going to do the same thing from K. Put my bullseye on K. And I better have kind of like an eye or a fish. And where those two things intersect, got to have a place where those two things intersect. This is your first perpendicular bisector of this side. Sometimes it may go through this vertex, sometimes it may not, but that's congruent to that. What I will need to do from there is I will need to do the same thing and do a perpendicular bisector of KL, maybe a perpendicular bisector of JL where they intersect. That's your circumcenter. You could even figure out the circle that goes through all three corners. That's the fun part of number 2. Does anybody need me to go and do the next step, or you feel like you can do the rest of this on your own? If you feel like you need further directions, raise your hand so I can see how many feel like they need more help with this. 1, 2, 3. Okay, we'll do one more. I'm going to go over to K. I'm going to put my bullseye on K, and I'm going to make sure that my slider is more than halfway. I adjust my slider, I tighten it up, I make an arc. Then what I do is I put my bullseye with the same distance on L, and I make my other arc using the same hole as I did before. Went from L, went from K, more than halfway, and then I got this I, and then I can go from the point of intersection here to the point of intersection there. I'm going to use these two intersections to find the perpendicular bisector. Perpendicular bisector. I could do the third side if I wanted to, but I already know where it's going to intersect. It's going to intersect right here because this point right here is the circumcenter. And if you really want to check, did I get it right? If it's the circumcenter, won't a circle go through all three corners? So then you can put your bullseye on the circumcenter if that's what you think it is, and adjust your slider until you get to the corner, and then you can check. Let's see how good we did. How good did we do? How good did you do, I should say? Does your circle look like mine where it goes through all three corners? If not, you need to be more accurate in your perpendicular bisectors. What I did from there is once I found it, I adjusted until I got to a corner. I made sure this hole was directly over a vertex. Then I tightened up my slider. That way I would have that distance the same. Next example. I'm going to jump to number 4. We are going to use perpendicular bisector for 1, 2, and 3. When we start getting into incenters, we need angle bisectors. You may have forgotten how to bisect an angle. So what I'm going to show you is the same method for bisecting an angle is what you would do for number 5. So I'm actually going to skip number 4, and I'm going to just jump right. You would use this method for number 4 as well. I'm going to jump to number 5. I need the angle bisectors. I'm going to start with my compass, bullseye on point C. And what I'm going to do is I'm going to start off with a fairly small arc. This one's going to be just about, let's say, 1.5 centimeters as my radius. That's how far this one's going to be. I don't know if you guys can do that or not with yours, but I can tell. I'm going to make an arc from point C. That's where I'm going to begin here. Let me zoom in just a little bit more. I made an arc from point C. Every construction starts with 2 points that are equidistant. This point is equidistant, and so is this point. What I'm then going to do is I'm going to move my bullseye to these two intersections using the same distance. So I'm going to put my bullseye right here on this intersection. Put my pin inside, and somewhere in the middle it's going to be right about there. So I make an arc using this as the center. That's what my next one is. I'll just kind of leave that there so you could see. If we made that arc from that bottom intersection of the first arc, we're going to have to do the same thing from the second arc. I go over here to that first arc at the second intersection point, and I make another arc. It makes this sort of X. That's exactly in the middle of this. It would actually be a rhombus. I'm not sure if you could tell that or not. This distance is the same as this distance is the same as this distance is the same as this distance. So it makes this little diamond shape. All I have to do is connect the vertex through that X, and I have now found an angle bisector. So to walk you through it one more time, if I were to say what I did, I drew an arc, first step. It made two intersections points, this 1 and this 2. Then I put my bullseye with the same distance. From 1, I made an arc, and from 2, I made an arc. Where they intersected, I went from this vertex through that point and extended the line. That's an angle bisector.
It doesn't matter what distance you use to start off?
Nope. I made it relatively small so that it would fit inside. I didn't want to go and use the whole piece of paper. You can make it as big as you wanted to, though. And that's one angle bisector. We're going to do that again. You're going to use this same method for number 4. I'm going to do angle B, just because. Same arc. Step 1, angle B. Bullseye's on B. Nice small arc. It makes this little happy face, and where it intersects, I'm going to put a 1 and a 2, and I'm going to use the 1 and 2 as my next two centers where I'm going to put my bullseye at next, where the 1 and the 2 are. Same distance. I put my bullseye on 1, and I know my angle bisector is going to be somewhere in the middle, and same thing with number 2. It's going to be somewhat in the middle, and I'm going to make 2 arcs from there. Where they intersect from the vertex to there makes 2 perfectly congruent angles. If I were to measure this angle and measure this angle, they should be exactly the same measurement. Which means this should be the in-center. I could do and figure out this other side, and just for good measure, I'm going to do the exact same thing from A. I'll put a 1 and a 2 there. Put an arc out there in the middle. An arc out there. And if I connect those dots, which I'm doing really quickly this time, it should go through the same point, which it does. There's my in-center right there. if you would like to see, is this the in-center, is this the place where I could draw a circle inside this triangle, then what you could do is you could put your bullseye here on the inside and then adjust your slider until this hole is directly over a side, right in the middle. Like, oh, there it is. And you could check to see, does it actually make a circle on the inside? And if you're good, it will. Let's see. How good did I do? That ain't half bad, Mr. Promo. Perpendicular bisector is how we make the circumcenter. Angle bisector is how we make the in-center. So the next one is, how do we make the centroid and how do we do the orthocenter? These are the last two that we're going to cover. Let's do centroid. Centroid is what we just learned today. It's from a vertex to the midpoint on the opposite side. Now we could do the midpoint in a bunch of different ways, but the easiest way to find a midpoint is this. Measure it 6.4 centimeters. Cut it in half. What's half of 6.4 centimeters? 3.2. Make a dot at your midpoint. Draw from your vertex to the midpoint, and that's your median. That's the easiest way to do it. We could use a perpendicular bisector to figure out the midpoint if we didn't have the ruler, but since we have the ruler and this is about figuring that what's what, we can do it this way. I'm going to do it this way. I'm going to measure AB. From A to B, I'm thinking it's 7.1. I'm going to go 3.5, just a little bit more than 3.5 right there. Boom. There's my midpoint. So from C to that midpoint, I'm going to measure BC. Just under 5. 2.5 would be 5, a little less than 2.5. Connect the dots from A to that midpoint. And guess what? They all intersect at the same point. There's your centroid. I already used A, B, and C, so I gotta call it something else. I call it O. There you go. Last one is the orthocenter. The orthocenter, this one is something that we haven't done a lot of because we need to figure out the altitude. Altitudes are sort of hard to find unless you have 2 points from here. So here's what we're going to do with the orthocenter to find the altitude. We are going to need to extend lines sometimes. For example, right now I'm going to extend the line of XZ. I'm going to make this just a little longer. Start off with that. Make it a little longer. It'll make your life easier if you extend XZ. The next thing you're going to do is I'm going to find the altitude that goes through vertex Y. So I'm going to put my bullseye on Y, and then I'm going to extend my slider until this hole is past this side. It needs to be longer than side XZ. Once your slider is longer than that, what you are then going to do is you are going to make what I like to call is a happy face. Smile. It has to just be longer and create 2 points of intersection. Anywhere longer than the distance from y to xz. After that, you can put a 1 and a 2 right there. Because that's what you're going to use next to figure out where your perpendicular point is. We now have these are equal distances. We're going to find the place that would be the same distance below there. I take this, I put my bullseye on 1, and I can use the same distance or I can shorten it up if I need to, but I'm going to pretend that this is going to be directly below that y down here somewhere, and now I'm in the other graph, but that's okay. I'm going to make an arc from bullseye being on 1 down there. Let me scoot that up just a little bit so you could see. If you did that from bullseye on 1, we're going to have to do the same thing from bullseye on 2 with the same distance. Try to be accurate. So what we have is we have this other rhombus that's going to be straight directly between y and here. Here's my first altitude. Thank you. There's my first altitude of this side. Now I have to do the same thing for this vertex or this vertex. Let me choose vertex Z. If you want to follow the same, you might want to rotate your whole paper around, but because I know what I'm doing, I'm going to leave the Z right there. And I wonder if I need to extend this line. I might need to extend this line, so I'm going to extend this line as well, just in case. I'm going to put my bullseye on point Z. I'm going to adjust my slider to make sure that I'm just a little bit past, not too far past. Tighten it up, and then I make my happy face. I guess I did not need to extend the line on this one because I have my 2 points of intersection. I have a first intersection and a second intersection from point Z. And then all you have to do from there is put your bullseye on the 1. Your altitude will be somewhere up there. Put your bullseye on the 2. You get this X. This X would make a perfect rhombus. And so I'm going to connect this X with that vertex, and I know that this is a perfect right angle to that side. Altitude, altitude. We need one more altitude, which should go right through that 1 point.
When doing Z and measuring past the line, what length do you use?
Doesn't have to be any length. It just has to be longer to where we have 2. I could have done the same thing even farther if I wanted to. It can be out here. As long as it touches the side on both sides, you're okay. You will get the same thing.
Then we're doing the length of 1 and 2. Is it the same one that you use?
I use the exact same length. I copy that same length out there. Because I wanted to fill my paper, I kind of had a little bit shorter. That's why I went to here instead. There. There. I'm going to do the other side. And I'm going to do it from X. And then, will I be able to make 2? I don't know. Let me see. I'm going to have to extend this side, aren't I? I will have to extend this side. Now what I can do is go a little bit past. Make my smiley face, put a 1 and a 2. Go over to the 1. Arc. Ooh, that wasn't even close. Arc. Arc. And then connect the lines. Ooh, I might need a longer ruler. And I could tell that I had messed up somewhere because see how I have a little gap right there in between? Oh, that's my margin of error. That's how, like, oh, I was close, but you know, one of these isn't exactly at a 90-degree angle. Otherwise, they would all intersect in the same spot. That's just my margin of error. I'm going to stop your notes right there.